This video we're going to look at how we use vectors in mechanics. So for a body moving with constant velocity, you know acceleration, the following vector equation is used. So this is displacement is equal to velocity times time. So displacement and velocity are both vectors, where time is just a scalar, so that's just a number basically. The following constant acceleration equations also work. So you've got your velocity, final velocity equals your initial velocity plus acceleration times time. Your displacement is equal to your initial velocity times time plus a half times your acceleration times time squared, or your displacement is equal to half times your initial velocity plus your final velocity times time. Also, the bonus one is the following. It is your displacement is equal to your final velocity times time minus half times your acceleration times time squared. First example says a body moves with constant velocity. So it is v is equal to 7i minus j meters per second. Find its displacement after 5 seconds. So we're just using the formula s is equal to vt. So s in this case is equal to your 5 times your 7i minus v, which works out to be that your s is equal to 35i minus 5j, and that's going to be meters. Next example says a particle sets off from the origin and after 10 seconds of travel at a constant velocity has a displacement of 20i plus 30j. Find the velocity of the particle. Okay, so it's a constant velocity, so you're saying s is equal to vt, and you know it has a constant velocity, and you also know that your s is equal to 20i plus 30j, and that's equal to my time, which is 10 times v, which means v is just going to be equal to 20i plus 30j. I'll put that in a bracket because that's all being divided by 10. So your v works out to be 2i plus 3j. Put that in a bracket, that's going to be meters per second. Okay, body's moving parallel to the vector minus 5i minus 12j with a speed of 65 meters per second. Find its velocity. Okay, so it's going parallel to this direction here. So I want to find the size of this direction here. So I'm going to just say let v equal minus 5i minus 12j. And what we're going to do is find the size of it. So this, remember how we say this, the modulus of it, or the magnitude of it. So it's going to be minus 5 squared plus minus 12 squared, and square root of all that. So you file that into your calculator, what you'll get is 13. So basically this vector up here is size 13. We just say, so v is 13 units, and we'll say 13 units long. So if something is 13 units long, and we want to get it to be 65 units long, what I could do is divide it by 13 and then multiply it by 65. So we will just say our vector needs to be, so we're going to be, needs to be equal to, so we're going to divide it by 13 and then multiply by 65. So that's the same as multiplying by 65 over 13 times the minus 5i minus 12j. And we're just going to do that on our calculator. So, well, first of all, it's quite nice one because 65 divided by 13 on your calculator, just check that if you need to, is just going to be 5. So it's just 5 times minus 5i minus 12j. And when you work it out, you get minus 25i minus 60j, and I should need to put that in bracket. That's my meters per second. That's a very tough example, so just run through that again, what we've done. Okay, we were told we wanted to find a vector such that it's moving parallel to minus 5i minus 12j and it has a speed of 65. So we need to define the size of this thing as v, which is equal to minus 5i plus minus 12j. So we find its size by doing its modulus, which is the square root of minus 5 squared plus minus 12 squared, we got 13. So we know that this thing that we call v is 13 units long. So to make it 65 units, you need to divide by 13, which is the same as multiplying by 1 over 13. That gets it down to size 1, and then multiply by 35 to get it up to 65. Multiply by 65 to get up to 65. And in this one, and you could do this in your calculator if you don't like this wee bit I've done, you could just do 65 over 13 times minus 5 would give you minus 25i. 65 over 13 times minus 12j would give you minus 60j, and remember, meters per second. Okay, this question says challenge question, so it's not going to be easy. A body is initially at a position vector minus 2i plus j meters, travels for 4 seconds at a constant velocity of minus 7i minus 0.5j meters per second, find a new position vector. Okay, I'm going to say first of all, change in displacement equals, so I traveled for 4 seconds and my velocity was minus 7i minus 0.5j. Now if you do that, what you'll get is minus 28i minus 2j. So then my final displacement is equal to my initial displacement, which was my initial position vector of minus 2i plus j. I'll put that in the bracket. Plus then my change of displacement, which was minus 28i minus 2j. And if you do that, what you will get is minus 30i and minus j. And that's going to be meters. And that is it. So first thing I needed to find the change of displacement, so that was my 4 seconds times this velocity that I was going, and then add that on. So I found that to be minus 28i minus 2j, and then add that on to my initial displacement. Okay, in this question it says a body accelerates from rest at 2i plus j meters per second squared. Find the velocity of the body after 4 seconds and the distance traveled during this time. So we know my t is equal to 4 seconds, and my accelerate from rest, so my initial velocity, I should say, is 0i plus 0j. So it's going from rest. Okay, we want to find the velocity after 4 seconds, so we're just going to say v is equal to u plus a t. So v in this case is just equal to 4 times, my u is 0, remember, so it's just my a times my t, so it's 4 times 2i plus j. And if you do that out, it's going to be equal to 8i plus 4j meters per second. Okay, it also says find the distance traveled during this time. I'm going to use my s is equal to, and I'm going to say ut plus a half a t squared. And remember, my u was 0, so that's just going to be 0, plus a half times my a. What was my a? My a was 2i plus j, and my t was 4, so that's going to be 4 squared. 4 squared is going to be 16. 16 times a half is going to be 8, so that's just going to be 8 upon 2i plus j, and I'll just multiply it out for my final answer. J is equal to 16i plus 8j, and that is going to be meters. Okay, this example says a particle has an initial velocity of I plus j meters per second and accelerates 2 minus 2i plus 15j meters per second over 10 seconds. Find the magnitude and direction of acceleration on the particle during this time. Okay, so what we're looking to find here basically is A. So you're going to use V is equal to U plus AT. And these ones, I know normally I would put in the values to do this, but in these ones I find it slightly easier just to rearrange the formula. So V minus U divided by T will be equal to your A. So there's my T, my V minus U. So minus 2i minus another I will be minus 3i. And then 15 j minus j would be 14j, which means your a works out to be minus 0.3I plus 1.4j. So that's your acceleration. What the question asks you to find is the magnitude and direction of acceleration. We'll do a diagram, I think, for this one. So you are going 1.3 minus, sorry, it's minus 0.3, I should say, 0.3I. Get rid of that, that's a mess. So it was 0.3I. Let's go, or minus 0.3I, and then you're going up 1.4. So this is your acceleration. I'm going to have to find that angle. I'm going to have to find the magnitude of it as well. So to find the magnitude, it's going to be the square root of the 0.3 squared plus the 1.4 squared. I'm going to do that on my calculator. I'm conscious I'm running out of space here. So 0.3 squared plus 1.4 squared, square root of all that. What it gives me, I'm just going to give this as a decimal, is 1.43 meters per second squared, and that's to dp's. And also I'll say tan of theta is equal to 1.4 divided by 0.3, because tan is equal to opposite over adjacent. So tan to minus 1 of 1.4 divided by 0.3 works out to be, my theta works out to be 77.9 degrees. I've given that to 1 dp, so 3 sig figs really, they both are, and that's it. So that is above horizontal as well. Okay, tough question this one. It says the body moves parallel to the vector 4I minus 3j with a speed of 30 meters per second. So it moves parallel to this. I'm just going to say let v equal 4I minus 3j. And I'm going to find the size of that thing. So the size of that thing is going to be 4 squared plus minus 3 squared. And the square root of all that, and you will get 5. So RV has size 5. Okay, so it needs to be multiplied by 6 to get size 30. Why we're wanting size 30 is because we wanted it to have a speed of 30. Okay, so that means, so our vector, our velocity I should say, our velocity is equal to 6 times our original thing, so 6 times 4I minus 3j, and when you do it out, what you're going to get is 24I minus 18j meters per second. Okay folks, so all we have found here is that we have got 24I u is equal to 24I minus 18j. That's all we've got so far. We also know it accelerates at a constant rate of I minus j, and it does this for 3 seconds. So then what we want to find is a final velocity, and then we can find the final speed. So your v is equal to u plus at. So your v is going to be equal to 24I minus 18j plus 3 times my acceleration, which is I minus j. And if you do that out, I would do out my calculator, do the i's first. 24 plus 3 is going to be 27I, and then minus 18 plus 3 times minus 1 is minus 18 minus 3, which is going to be minus 21j meters per second. So then we'll finish this up. So your speed, remember, is equal to the modulus, or the magnitude, of the velocity, which in this case is going to be the square root of 27 squared plus minus 21 squared. And then we'll just do that out and see what we get. So what if I just said 27 squared plus minus 21 squared, all square rooted, and I got an answer of 3 root of 130. I press SD obviously to get it, and it's going to be 34.2 meters per second, and that is to 1 dp. Force is also a vector quantity, which gives rise to Newton's second law in vector form. So this is your vector F is equal to mass times your vector A, and mass is just a scalar. Mass just has size, nothing else. So a particle of mass 7.5 kilograms experiences a force of 9I minus 19.5 J. Find its acceleration. So your acceleration is going to be your vector force divided by m. So in this case, that's going to be 9I minus 19.5 J, all being divided by 7.5. So if you do that on your calculator, 9 divided by 7.5 just gives you, and that's 1.2. So 1.2I, and then minus 19.5 divided by 7.5 just gives you, and that's minus 2.6. And that's going to be J, and that's going to be meters per second squared. Okay, this question says a 5 kilogram mass is acted upon by the forces of 3I plus 8J and minus I minus 7J. Find the overall force acting on the mass. So your force is just going to be those two things added together. So 3I plus 8J plus, what's the other one, minus I minus 7J. And if you add those two things, you're going to get 2I plus J newtons, and that is it. Okay, part 2. Part 2 says find the velocity after 10 seconds if it started from rest. So first of all, you need to find your acceleration again. So like your last question, acceleration is going to be your F divided by m. So your acceleration in this case is going to be 2I plus J divided by your m, which was 5. So if you do that, your acceleration is going to be 0.4I plus 0.2J. That's going to be meters per second squared. Always forget my brackets, meters per second squared. Okay, and then it says, haven't quite finished this one, find its velocity after 10 seconds. If it starts from rest, so 0 is my u, my t is 10, my acceleration, I've worked it out to be 0.4I plus 0.2J, and we can say our velocity is u plus at. So in this case, it's going to be 0 plus 10 times the 0.4I plus 0.2J. So your velocity works out to be 4I plus 2J, and that's going to be meters per second. The last part of it says the position vector of the mass after 10 seconds if it started at the origin. So we are going to say our S is equal to, and I'm just going to use a half, sorry, it's not a half at all, I'm going to just use, get rid of that, that's nonsense. S is equal to UT plus a half AT squared. And I use this one because it's easier just because my U is 0. And then I've got a half times my A, which we had worked out earlier on to be 0.4I plus 0.2J, and then times my T, and my T was 10 squared. So if you do that out, a half times 10 squared is just going to be 50 times the 0.4I plus the 0.2J, and I would just do something like that with my calculator just to check, and you're going to have, that's going to be 20I, and then that's going to be 50 times your 0.2, and 50 times your 0.2, we should have known, but just check, and especially in the exam, I would just check that, and that is going to be 20I plus 10J meters. Okay, last example says a particle of mass 4, so your mass is equal to 4, accelerates from 5, so your u is equal to 5I to 2I minus 8J, and it does that in 6 seconds. Find the magnitude and direction of the force. So before we can find the force, you've got to find your acceleration. So we're going to use V is equal to U plus AT. So, and then we're just going to rearrange that to just find that easier to rearrange. Make A the subject, V minus U all over T. So your A is equal to, so if you do your V minus U, you'll get minus 3I, and then minus 8J. And then if you divide by your T, what was our T? Our T was 6. That is what you're going to get for your A. So I'm going to leave it in fraction form, this one. This is going to be minus a half I, and I'll just leave it as minus 8 over 6. Well, I could cancel that down, but I've just left it now as 8 over 6. That's fine. I'll write it again up here. Now it is equal to minus a half I minus 4 over 3J. So that's what my acceleration is. Okay, it says find the magnitude and direction of the force acting on the particle. So let's find the force first of all. So your force is equal to your m times your a. So if you multiply this thing by your a times your 4, you're going to get minus 2I, and then that's going to be minus 16 over 3J. And let's do a diagram of this thing. So it's going 2 to the left, and then it's going 16 over 3 down. So there's your force, and there's your direction. So to find your F, modulus of F is going to be 2 squared plus 16 over 3 squared. And then we're going to square root of all that and see what we get. Again, onto your calculator. What have I said? 2 squared plus brackets, and it was 16 over 3. Close your bracket squared, press equals, and what I have got, I'm going to just give that as a decimal. It's 5.6960. I'm just putting that in to show you. So the 3 sig figs is going to be 5.70 newtons, and that's the 3 sig figs. And then I have my tan theta. Tan, remember, is opposite over adjacent, I should say. So 16 over 3 being divided by 2. So that means your theta is equal to tan to minus 1 of 16 divided by 3, 16 over 3, sorry. And then that's being divided by 2. Close your bracket, and I have got 69.4 degrees. And we'll say below the horizontal. Okay, that is us done.